In 1984, Taiwanese company Tatung released the Einstein TC01 computer. Although initially aimed at small businesses, the Einstein gained popularity among software developers due to its reliability and CP/M compatibility. With its large footprint, it had many interfaces, including an RF modulator TV output, volume control, 2 joystick ports, standard RS-232 for comms, YUV and RGB video, printer port, general user I/O. The Tatung pipe for external expansion, external discs, a reset button and a power switch. So let's open it up, fix what we need to and review this Tatung Einstein TC01. The Einstein's lid is secured by 2 screws. Inside we can see a large speaker, the system board, the floppy drive with dual drive connectors and the power supply. So let's remove all the components until we get to review the system board. The Einstein's board is split into the following sections. So, looking at the board itself, we can see the floppy disk controller, the Z80 CPU running at 4 MHz, an 8K ROM housing the machine operating system, space for an additional ROM. However, the only ROM I could find was this diagnostic one uploaded in 2019. And this asterisk on the circuit diagram indicates that this is optional anyway. Moving on, we have the Zilog I/O chip supported by this serial data controller, a counter used to generate communication baud rates, 64K of RAM, lots of logic components, 3 channels sound, 16K of video RAM split across these 2 chips, which is memory mapped using the video display controller, resulting in this memory map, which from my research I think is right, but happy for any corrections in the comments. The rear of the system board is clean. However, there are 2 bodge wires. So let's clean up the board and reassemble what we can. As we saw previously, some of the keys are stuck. And inspecting the rear of the board, we can see that each key switch is actually soldered. Let's take off the keycaps and inspect the switches. And desolder one from the board, which appears difficult to repair. And as there are no replacement new or old stock parts, let's use this non-functioning Einstein as a donor and swap out the faulty key switches whilst we jump into our keyboard fix montage. Next up is the power supply, which has some fairly large capacitors, and given at the time of recording it's 41 years old, we'll replace it with a new one. But before we do that, to make retro computers less cumbersome, let's replace that tethered power cable, which I'd normally do by installing a C14 socket connector. However, we can't do that without cutting into this case. So what we'll do is clean up the existing power cable and install a C14 plug. Then, using this new PT65B power supply, let's configure the harnesses for the standard 230 volt input, and on the other side our -12 ground, +5 and 12 volts. Installing this into the original case is going to short the power supply. So let's create and install a custom 3D printed mounting plate and update the wiring harness to fit our new power supply. The Einstein uses 3-inch floppy drives, and disks have a capacity of 180K on each side. Let's remove this jumper from Disk Select 0, noting there are 3 additional device number options, 1, 2 and 3. Placing the jumper on DS1 selects Disk 1, which means we should now install this drive into slot B or 1. This is because we're going to replace the A or 0 drive with a Gotek, allowing us to load software from the internet and save them on USB drives. And as the drive fascia height is 5mm higher than normal, let's download and 3D print this updated version. Secure the Gotek to the mount. Slide the liquid crystal display board into the housing and connect to the Gotek board. And speaker for emulated disk drive access sound effects, whilst noting this Gotek is already configured for drive 0. So, whilst we add our mounting screws and secure to the Einstein, let's jump into our next montage. To use this original Tatung color monitor, we need to do a few things. Using this diagram, make an RGB video cable with 6-pin DIN plugs. Ensure the system board video jumpers are set correctly. And slide the monitor select switch to YUV RGB. Powering on, we can see our keyboard test works, but we need to improve our video display by using this SCART LCD monitor, which means we need this new RGB video cable. So let's connect the cable to the RGB for video, analog port for additional power, before powering up the Einstein again. MOS is the core firmware and manages the system's base functions, and as a machine code monitor allows us to perform direct commands such as converting decimal to hexadecimal, hex back to dec, interrogate memory contents using the tabulate command, use the fill command to set memory content, in this example zeros, and tabulate our results. And review our internal Z80 registers using the display command. We also have Crystal DOS, which allows us to access our disk drives. So let's download some files from the internet, copy them to the USB and place it into our Gotek. Performing a directory listing on the USB drive displays the Manic minor file. Let's place a 3-inch disk into drive 1 and do a directory listing. and test we can copy from the 3-inch disc back to the USB drive. As both the USB and original drives have now been tested, let's load and play our first game.